Hello, Chem students. Today we're going to talk about some of the initial information associated with chemistry. We're rounding out the season, rounding out the school year. We got 2 more weeks left. I'm going to give you a barrage of short videos talking about some of the basic concepts that are usually covered as a overlap of what might have been in middle school. But we're going to go ahead and knock these out and just give you some nice refresher of some of the stuff that you might have carried through. So first thing, today we're going to talk about different classifications of matter. So definition, matter is anything that takes up mass and takes up space. So it has mass, has some inertia to it, and it takes up some space. So here's some examples. Iron is a type of matter, a chair is a matter, air is a matter. Even though you might not realize air has mass, it does. Wave your hand in the air, you can feel it. Water, books, salt, anything that, one of the classic examples, and I say classic only because it's a kid example, is stuff. Anything that is stuff, you can see it, it has some to it. That's something that is matter. Things that are not matter, light is not matter, fire is not matter, thoughts, ideas, emotions, feelings, those are all not matter. It's not that they don't matter, they are not matter. So classification of matter, we're going to classify ourselves into 2 major categories to begin with. So we start with identifying whether something is a mixture or a pure substance. As the names imply, a pure substance is something that's pure, and a mixture is a combination. So pure substances only has one kind of element or compound in it, but it is all that one thing. For instance, diamond is a pure substance. Diamond is just made out of pure carbon. Carbon atom, carbon atom, carbon atom, carbon atom, carbon atom, ad infinitum. Types of pure substances. There's elements. Elements are the things on the periodic table. It's just that simple. Anything that is on the periodic table is an element, hence the term the periodic table of the elements. They are the building blocks of all other matter. And then, so examples would be iron, sodium, carbon, oxygen, fluorine, tungsten, molybdenum. All those elements on the periodic table are all elements. Misconception. This does not mean that the element in nature is always a single atom. For instance, you should already know, because we've done this part of stoichiometry, that there are some elements that exist in nature as a diatomic molecule. So the element of hydrogen exists in nature as H2. The element of hydrogen versus the molecule of H2, there's a difference. Second thing is a compound. I apologize if there's noise. Today it's raining outside, so cars are driving by and making a little bit of noise. So if you hear that, I apologize. Okay, other type of pure substances are compounds. That's when you chemically combine 2 or more of the elements together. So for instance, hydrogen, H2, is a compound. It has 2 or more elements, an H and an H, they happen to be the same one, and they combine together. And they're joined together through a chemical reaction or a chemical bond. And each compound will have its own unique set of properties. So example, water, H2O, is a compound. Salt, sodium chloride, is a compound. Carbon dioxide, CO2, is a compound. Anything you can write as a chemical formula is going to be a compound. So you have matter, can be broken into 2 categories, pure substances and mixtures. And in the pure substance category, you have elements and you have compounds. Elements are one element over and over again. Compounds have the different elements covalently or ionically bonded together, chemically bonded together. Then on the other side, you have mixtures. Mixtures is when you have a combination of 2 or more substances. Well, isn't that exactly what we said a compound was? No, here's the difference. Mixtures are not chemically bonded together. A mixture is not chemically bonded together. It is just sheerly happens to be in the same space. Their individual identities are kept unique. Okay, so for instance, I show the picture here of this trail mix, and this trail mix has raisins and M&Ms and looks like cashews and almonds and all these good, and peanuts, all this in there. Well, each one of those pieces maintains its identity. That's a mixture. Trail mix is not a compound. There's no chemical bonds between the cashews and the almonds. Okay, And whenever you mix them together, that's going to be a physical change. And you should remember from middle school the difference between a physical change and a chemical change. A physical change does not alter the identity of the substance. Those substances in that trail mix are not altered. In the category of mixtures, there's two different classifications. You saw this on a slide a little earlier. There's homogeneous or homogeneous. I'll say homogeneous. Homogeneous, and there's heterogeneous. Homogeneous means it's uniform throughout. Now, there's a funny little distinguishing, whether you can see the differentiation. Even, uniform, distribution. So I always use like vanilla ice cream is a homogeneous mixture. Milk is a homogeneous mixture. Butter is a homogeneous mixture. So things like that are homogeneous mixtures. However, if you've ever had, and I'm going to date myself a bit, but say a Breyer's ice cream where they had those little specks of vanilla beans, that would not be a homogeneous mixture because you can see the different parts in the mixture. It is still a mixture, but it's a very similar composition, but the fact you can see the specks would make it not homogeneous. So, under homogeneous mixtures, there's two different categories. There's solutions and colloids. Sorry, actually solutions and suspension. Solution, it's another word for, and we're going to go a lot more into solutions in another video later on in the series, talk about what solutions are and how they are different than everything else, but we're going to mention them really briefly. A solution, something like Kool-Aid is a solution, something like soda is a solution, tap water is a solution. Okay, you have some things dissolving in other things. The solvent is the thing that's doing the dissolving. In the case of Kool-Aid and soda and tap water, the solvent is the water. Okay, the solute is whatever's being dissolved. In the case of Kool-Aid, it's the flavor packet or the sugar. That's what's being dissolved into the water. And when it all comes together, you've got what's called the solution. Now, one of the neat things about a solution is it's just so thoroughly mixed, you can't really see the particles at all. Therefore, it's homogeneous or homogeneous. But recognizing that there are two distinct different portions, the solvent and the solute. And again, in a later video and later on this week, we're going to talk a little bit about solutions and solubility. So you got the salt or the sugar, I guess, I don't know what they're dissolving in there, and you get the solvent. The solute is what's being dissolved, usually in a lesser quantity, and the solvent is what's doing the dissolving, usually in the greater quantity. Now, another type of homogeneous mixtures that you may not be aware of is a concept called an alloy. An alloy is a mixture of metals. Brass is a metal. Bronze is a metal. Stainless steel is a metal. Those are all metals, but they're mixtures of metals. They are a combination where the chemicals are not chemically bonded together. They're just mixed so thoroughly through smelting that they disperse the molecules consistently throughout. So examples, like I said here, brass, bronze, steel, solder, stuff that's made to put pipes together, copper pipes together. Brass is a combination of copper and zinc. Bronze is a combination of copper and steel. It's also copper and you'll have like manganese or nickel. Steel is usually a combination of iron and carbon, and one of them is not even a metal, but it's in the non-metal category. And solder usually is tin and lead. They're put together, they're mixed together so thoroughly that it forms what looks like a unique metal, but it does maintain the qualities of the individual metals. So for instance, steel, being that it's made out of iron and carbon, will be magnetic because it still maintains the characteristic of iron being magnetic. Then on the other side of the coin is the heterogeneous. Heterogeneous is non-uniform. So a taco is a mixture. When you mix that taco together, that taco salad or that Rocky Road ice cream, you can see the parts, you can see the lettuce, you can see the tomatoes, you can see the cheese. They're all separate, so you can see the different compositions. Now, what we want to do is think in terms of at what scale are we differentiating between heterogeneous and homogeneous? Well, it's a matter of the eyeball. If you can see the difference, then you're going to refer to it as heterogeneous. If it's homogeneous, is if you cannot see the differences. Okay, the molecules are going to be very, very much unevenly distributed in a heterogeneous mixture, whereas in a homogeneous mixture, normally they are very, very thoroughly combined so that they're super, super, super consistent across the entire container. Oh, there's those trail mix. Okay, so we look at these two substances, one on the left and one on the right. They are both mixtures. The one on the left is a piece of brass, copper and zinc mixed together. You can't really see the copper and the zinc molecules, but they're there and they're separate, but they're so thoroughly put together that you can't see them, so that is a homogeneous mixture. On the right-hand side is a piece of granite. It's heterogeneous. Why? Because you can see the specks. Heterogeneous, you can see the differentiation. Homogeneous, you cannot. Under heterogeneous mixtures, there's another two categories that are laid out there. It's called suspensions and colloids. And suspensions are usually when you mix together two materials, usually liquids. Usually the term is associated for liquids, but it works in the solids world also. Whereas you actually can see a separation of the layers. The classic example of a suspension is Italian salad dressing. If you've ever had Italian salad dressing, you know before you use it, you got to shake it up. If you don't shake it up, then you pour out the oil on top and you just get oily salad. You got to mix it up to get all the flavors and the vinegar mixed together, and everything has to be mixed together if you mix it up. But when you leave it by itself, they're going to separate out. That's a suspension. Okay, if you can see the particles and they have some layering or some separating out, that's going to be a suspension. Almost any heterogeneous mixture, with the exception of colloids, which we're going to talk about in a second, is considered a suspension because you have the particles suspended in another medium. Okay, so pizza, muddy water, Italian dressing, natural peanut butter, that's one's the chunky, orange juice, pulp, all those things. Big time, big time. A pizza is a heterogeneous mixture. You can see the particles, and it's a suspension. And then the other side is probably the hardest one to explain. It is a colloid. If you've ever been driving with your parents at night in the fog, look at those conditions, at night in the fog, then you probably notice, if you're paying attention, that the headlights bounce off of the fog, and maybe you'll actually see the beam of light from the headlights as you're driving through. That is showing you that fog is a colloid. Okay, what happens is it's a mixture, but you can't really see the phases. But if you shine a light through it, then you are going to see the difference. Okay, so for instance, things that are considered colloids are smog, smoke, air. Almost all dairy products are so clearly mixed that you can't see the difference, but they are different, and you can tell by doing what's called the Tyndall effect. The Tyndall effect is one where you shine light through it like you do with driving in a car, and when you shine light through it, if you can see the beam, if you've ever been at a campfire, you shine a flashlight through the smoke, you'll see the beam. They show on the right hand side air and like smoggy air. That's going to be one that's going to be able to see the beam. That's a colloid. If it's so suspended that it's not really visible, but you know they can be separated, that is a heterogeneous mixture. So here's a quick recap. Pure substances, just one thing throughout. Mixtures, two or more things throughout. Okay. Elements are just one thing, one element throughout, and compounds are combinations of elements. Mixtures, there's two types. There's the ones where they're evenly distributed, homogeneous, and not so evenly distributed, heterogeneous. We're going to talk a little bit more about states of matter and a tiny bit about chemical change, but more about physical change in a subsequent video. So, I'm going to wrap this up. I will see you on the next video revolving around mixtures. Toodles.